In this lesson, we're going to look at different ways to express formulas. 3 common ways to express the elements in a compound are the molecular formula, the empirical formula, and the structural formula. The molecular formula is what we typically see when we're looking at information about a compound. The empirical formula is the simplest whole number ratio of the elements in the compound. You can think of that kind of like a reduced fraction. The structural formula shows the connections between those atoms. And what we'll see, especially with compounds that contain a lot of carbon and hydrogen, is there are lots of different ways for these atoms to be connected. So sometimes the molecular formula is not enough to represent what that structure is. Let's look at empirical formulas. These have the simplest whole number ratio between atoms in a compound. For example, if I look at C10H22, I see that both of those subscripts can be divided by 2, which results in C5H11. So that is the empirical formula. And multiple compounds can have the same empirical formula. For P4O10, those are also divisible by 2, and we get P2O5. SF6 is already the smallest whole number ratio. In this case, the molecular formula and the empirical formula are exactly the same. Which two answers correctly match the molecular and empirical formulas? If I look at N2O4, its empirical formula should be NO2 because both of those subscripts are divisible by 2. For C6H12O6, each of those is divisible by 6, so we get CH2O, so that one is a correct choice. When I look at C, I see that their formulas are exactly the same and that the molecular formula already has the smallest whole number ratio between the elements. Therefore, the molecular and empirical formulas are exactly the same. When I look at answer D, C5H12O and C5H12, while both of these are empirical formulas because they're the smallest whole number ratios, they are not the correct match of molecular and empirical formulas because one of them has oxygen and one of them does not. Therefore, A and B are the correct answers. What is the empirical formula of C8H10N4O2? When we look at the formula, we can see that all of the subscripts can be divided by 2. Whatever we do to one subscript, we must do to the same thing to the others. When I divide that by 2, I get C4H5N2O. So D is the correct answer. We've previously talked about atomic versus molecular elements, so this is just a reminder. Atomic elements exist in nature as individual atoms. Molecular elements exist in nature as molecules, so 2 or more atoms connected together. The most common of these are the diatomic elements, which are highlighted here in yellow on this diagram. So for example, H2 and Cl2 are both examples of a molecular element. When I find hydrogen or chlorine in nature, it's always existing as H2 or Cl2. I don't find individual H atoms or individual chlorine atoms. Which one is a molecular element? Remember, I'm looking for molecular element, which indicates there has to be more than one atom, and because it's an element, it has to be more than one of the same atom. So B is our correct answer. When I look at A, it is an atomic element because there's only a single atom of helium. H2O is a compound because it has more than 2 atoms, but they are of different elements. Therefore, it's a compound. And the same thing is true for CO. It has 2 different elements, so it is a compound.